Good morning, class 8 students. I hope everyone is fine and they are still at home and they are safe. In continuation to chapter number 1, matter. The last time we discussed a couple of days ago was about change of state of matter. Now let's look back at this picture. If you would see that we have already studied that if we heat ice, it converts into water, and if we further heat it, it finally converts into steam. And also, if we cool it, steam, it converts back to water, and if we cool it further, we get ice back. That's how we have seen the daily working of refrigerator at our home. Now let's try and understand change of state of matter in terms of two parameters. One is temperature, and with that I'll be connecting pressure also, and the other is change in energy state. Now I told you earlier as well that in gaseous state the particles move very freely because the intermolecular force of attraction between them is very less. Now that means the random motion of particles, which gives kinetic energy to the molecules, is maximum in gases, and it is least in solids because the intermolecular force is very strong, and it does not let the particles to go away from each other to a larger distance. Now let's try and understand change of state based on that. What happens? Now see instance ice, which is solid. We provide heat to a solid substance. The molecules of the solid substance gains that heat energy, which increases kinetic energy of the particles, and the particles then start to move away from each other. However, intermolecular forces are strong. They attract the particles back. However, if we keep on supplying heat energy, the kinetic energy also increases, and also the distance between the molecules, which is the intermolecular distance, increases as well. This goes on increasing. Finally, the intermolecular forces of attraction is so weak that the solid substance starts converting into liquid. There is a change of state, which we call as phase change also. So this way, the energy of the substance, the state, increases. Okay? Similarly, if we have a liquid substance, we increase heat energy, kinetic energy of the molecules increases, it goes on increasing, and finally the intermolecular forces of attraction is not able to hold the molecules together, and they become so far from each other that a change of state from liquid to gaseous takes place. Okay, so this is in terms of energy state. You should know, as in 1 mark question, that if we ask you what will be the state of energy, in which state the maximum would be in solid or liquid or gases, we will not give you a whole detailed question based on that, but you should know how to answer it. You should be in a position to explain the change of state based on energy state, how the energy changes between the molecules if a change of state takes place. I'm sure pretty much you would be able to answer that. Now let's have a look at the temperature part. Now again, heating means increasing the temperature of a substance. So what we are doing practically is we are increasing the temperature of ice so that finally it converts into liquid state, and we are increasing the temperature further, and finally it becomes steam in gaseous state. Okay. Now on cooling means we are decreasing the temperature. Decreasing the temperature means that the particles are coming closer. Now what happens? You must have noticed during summertime when we are sitting close to each other, like in a classroom, like students are so close, and if it's too hot, we try to make some distance. We look for separation. We want to move away from each other, right? However, when it comes to winter and if it's cold and we are shivering, we try to come closer to each other. This is the same thing with the molecules and the particles as well. Okay? Now, so with temperature, you have seen that the change of state can take place. However, we have noticed that the water which boils at 100 degrees Celsius at sea level, if we take the same water to hill stations or hilly areas, the water starts to boil earlier. It does not boil at 100 degrees Celsius. It starts to boil at a temperature lower than 100 degrees Celsius. Even it is said, and it has been experimented, that at Mount Everest, water starts to boil at 71 degrees Celsius. It's the same water. So what is the difference? How come the temperature of at which the water starts boiling changes? What is the variation that has caused that? Now the variation that we can notice is the height. Okay. So what happens with height? It has been noticed that the atmospheric pressure decreases as we go up. So at mountains, the atmospheric pressure is less than what it is at sea level. So that means change of state does not only depend upon temperature, it also depends upon atmospheric pressure. So if we change temperature, or if we change only the atmospheric pressure, the change of state can take place. Or it can take place if both temperature and pressure is changed. Okay? One is sufficient to change it. However, combined together, they can also bring in a difference earlier than thought of. Okay? Now, also, as you can see, and you can notice from this diagram, and I have made one here as well, this shows generally how this S stands for solid, then G for gaseous state, and the liquid state. This generally shows that how we can achieve some changes from solid to liquid, and solid to gases, and gas to liquid, gaseous to solid, and in between solid to liquid and solid. Now, okay, so as you can see from the diagrams, this change of state, you must have read in 6th or 7th as well, is reversible in nature. Therefore, it is categorized as a physical change. Remember, a physical change is a change which is reversible in nature. If we reverse the conditions, we get back to the initial state. Okay, so this can be achieved by whatever the heat that was provided to water, take the heat back. We put it in refrigerator, it takes the heat back and gets converted back into ICE. Okay. Now Let's look at this diagram. Now the change in state is taking place. We want to give names to those changes. Those changes you are particularly familiar with since class 7. So I won't go much into details, I'll just touching on top of that. But I'm particularly interested as far as your class 8 is concerned in these two. Especially sublimation and vaporization. So let's quickly go through this. Whenever a substance changes from its solid state to liquid state, we know that is called melting. That process is called melting. And the temperature at which a solid substance melts to convert into its liquid state, that temperature is called melting point. Now my only request is, because you have already dealt with this question in class 7th as well, but I just want to reiterate, revise this point. Please make sure you know the difference between these two, melting and melting point, freezing and freezing point, boiling and boiling point, condensation and condensation point. This is the process. Melting, freezing, vaporization, condensation, sublimation, deposition. This is the process. Melting point is a fixed temperature at which that process takes place. Okay? So I'm sure you all would already be remembering it, and or let's take the resolution. Now moving on. As I said to you, I'm particularly interested in these two. Let's quickly take this term first, vaporization. Let's come to this side. I've written the definition for you, and I'll just before that I would just like to clarify one thing. It is vaporization. I have written. It's not evaporation, it's vaporization. So when a substance converts into its liquid state from solid state, when a substance converts into its gaseous state from its liquid state, that process is called vaporization. Okay? It's not boiling, it's not evaporation. In fact, evaporation and boiling are the two types of vaporization. So again, the process of converting a liquid state of a substance into its vapor form or gaseous form, that process is called vaporization. And evaporation and boiling are its two types. Let's quickly see the difference between these two. What is the difference then? We are familiar with this term evaporation. We are familiar with this boiling. So what is the difference? Let's check it out. Evaporation, by definition, it is the process in which liquid changes into its vapor state below its boiling point. Any liquid that we have, it has some fixed boiling point. So, if the vapors are being formed at a temperature lesser than that, let's take water as an example. We know the boiling point of water is 100 degrees Celsius at sea level. However, we have seen that if we keep a beaker full of water under sunlight, like these hot days, if we keep it for like 2-3 hours, after some time we will start noticing that the level of the water, even less, has gone down. Or the best example, during summer, we tend to sweat. However, if we switch off a fan, the sweat gets vaporized. Okay, so that is evaporation. However, when it comes to boiling, it is that process in which liquid only changes into its vapor state at or above its boiling point. So if the vapors of water are being formed and the temperature is less than 100 degrees Celsius, this is evaporation. And if the temperature is 100 or more than 100, then the liquid is getting converted into vapor, that is boiling. Okay? Now, there is another sharp difference between these two. Evaporation, it takes place only at the surface. If we take a beaker full of water, the surface level water, only that water molecules get evaporated. The water inside the beaker or at the bottom, that cannot get evaporated because evaporation is a surface phenomenon. However, if we talk about boiling, it takes place throughout the whole liquid. So whenever we take water at 100 degrees Celsius, whenever the water is boiled at 100 degrees Celsius, the whole water would get converted into vapor. There would be nothing left. Third point, evaporation causes cooling. It has a cooling effect. Again, at the same example, when the sweat of our body, it evaporates, we feel a little bit cold. Not cold as in start shivering, but it gives us a respite to heat. Now, drying of clothes, the clothes that we put outside on our roof, they get dried, the wet clothes after washing, they get dried due to evaporation taking place. Also, especially the girls would know, the nail polish remover, when they use it on the skin, it gives you that cooling effect. That is also evaporation, because what we use is acetone in it, and acetone, the boiling point is much below them. It's approximately at room temperature, so it evaporates very easily. Evaporation is a slow and silent process. That means it is taking place very slowly, and it is taking place all the time, 24/7. Even though the temperature of, say, again we talk about water, if the temperature of the water is 20 degrees Celsius, still evaporation is taking place. Even though if the temperature goes down to 0 degrees Celsius, or very close to zero, or in negative temperature, still evaporation takes place. It's just that the rate of evaporation becomes very less, and it's a silent process. However, when it comes to boiling, it's a faster process, and it's a very rigorous process. It takes place very vigorously. You can see the molecules jumping and vigorously. Again, the last part, I've given you the examples already. Which I told you, the boiling, it is heating water at 100 degrees Celsius, which gives us the example already. Okay, so with that, I would just like to end today's lecture. However, before I go, I'd just like to remind you that I know that there is a chapter called Matter by the same name in chemistry as well. So you must be studying awful things which are similar in both physics and chemistry. in the same chapter. But there is a difference when it comes to physics. The terminology that is used is little different in physics than what it is used in chemistry. So I want you to all pay attention, because the questions which are asked are not the same as asked in chemistry. So you should know the physics behind it. In physics, it is important to know how and why and reasoning questions, because in the next part we will be studying the second process which I am very much interested in, that is called sublimation. Okay? And there are a lot of reasoning questions based on that. Like, for example, you must have noticed that there are few substances which changes directly. And before that, let's quickly let me write the definition of sublimation for our common understanding, so that we are on the same page. This is a process in which a substance changes directly into gaseous state from its solid state without first changing into its liquid state, is called sublimation. This is very important. You write without first converting into its liquid state. Okay, so we'll take up these questions, and please, it's my humble request, please go through these video lectures, and the question assignments that we are making for you, try to solve it on your own. In case you have any questions, please click on the link that is given. You know that YouTube link is given. Don't click on the picture, click on the link, so that it directly takes you to YouTube. Subscribe it. There are many videos which are not showing to those who are not subscribed to the channel. So click on subscribe so that you can see all the videos. If you have to go back to the videos, because we have to keep on deleting a few in our camera phone. Sometimes it's not visible on the YouTube, so you have to subscribe. And also you can, at the bottom there is a comment section. You can write in your questions, your whatever you think about the video there, so that I get to see those comments where if there is any gap and any question you didn't understand, so that it reaches to me directly. Or you can send me a WhatsApp on 97818 if you have any question. Thank you and have a good one.